Good morning, everyone. Kuna kitu?
Mmoja consultant under the share screen, yeah. They do share screens also ku enable disable.
So.
Haya.
Nianze tu juu time imeenda.
Yeah, true.
So, thank you. Good morning, students. Today we are talking about preparation of salts. Can you hear me?
Yes, we can.
Oh, you've muted all the students.
I've enabled them to, I've allowed them to unmute themselves.
Oh, I can get this. Now, last week we were talking about solubility of salts. You can hear me?
Yes, we can.
Yes.
Okay.
Yes.
Last week we were talking about solubility of salts, and we looked at the salts that are soluble and the ones that are insoluble. Now, we also said that the knowledge of solubility of salts is very important because it helps us, especially with two main things. That is the first one when you're preparing salts, and another one is when you are trying to separate the different kinds of salts. That is in case we have a mixture. Now, we looked at the salts that are soluble and the ones that are insoluble. Just before I go to the lesson of today, maybe there are some questions that came up. I didn't answer them, but I can just go through that very quickly. There was somebody who asked, what about the phosphate salts? Because we talked about the nitrates, sulfates, sulfides, chlorides, carbonates. We also talked about the bases. Then there's a person who asked, what about the phosphate salts? Now, all phosphate salts are soluble. I believe I've answered that. All phosphate salts are soluble. All phosphate salts are soluble. Another thing was also on, we are talking about carbonates, sulfates. What about hydrogen carbonates or hydrogen sulfates? Now, when you now have a hydrogen carbonate or a hydrogen sulfate, then let me say that all hydrogen carbonates and all hydrogen sulfate salts are also soluble. All hydrogen carbonates and all hydrogen sulfate salts are soluble. I believe I've answered those questions. Now, on today's lessons, we'll look at preparation of salts, methods of preparing salts. Remember when we were introducing this lesson last time, we said that the knowledge of solubility of salts will help us in knowing how the different salts are prepared. Therefore, when we're looking at that, we say that there are salts that are soluble and others that are insoluble, and we are looking at the solubility in water. So when we'll be preparing these salts, we'll be preparing salts based on their solubility. That is, we'll be looking at how we can prepare soluble salts and how we prepare insoluble salts separately. So maybe let's start with how to prepare soluble salts. How do you prepare soluble salts? Now, soluble salts can be prepared in various ways. And I'm glad that part of this lesson that we are going to learn today is something that we did in Form 1 when we were looking at acids, bases, and indicators. So let's start by looking at soluble salts. And soluble salts can be prepared in various ways. Maybe we look at around 4 or 5 ways of preparing soluble salts. The first way of preparing soluble salts is this one called the direct combination. Now, when you're talking about direct combination of elements, this one is whereby we just combine elements directly. For example, when we have sodium chloride, you can easily combine sodium and chlorine to get sodium chloride salt. Now, the first lesson on salts, I believe, was on different types of salts. Sodium chloride is which type of salt? Sodium chloride salt is which type of salt?
It's a soluble salt.
Soluble salt, that is in terms of solubility. But
Soluble salts.
Normal.
Normal salt.
Normal.
Yes, it is a normal salt. So
Normal.
when we are talking about direct combination, basically the salts that are formed by direct combination are normal salts. Like I've talked about sodium reacting with chlorine to get sodium chloride, which is a normal salt. We can even have magnesium reacting also with the chlorine, you get magnesium chloride. Those are also normal salts. So that is the first way of preparing soluble salt, direct combination of elements. Is that okay?
Yes.
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 Now, let's now look at, okay, somebody is saying, I repeat, we're talking about soluble salt. So we've looked at the first method of preparing soluble salt. And we've said that it is direct combination of elements. And I've just said that in such a case, we produce normal salts. For example, sodium and chlorine, we get sodium chloride. Even if you have aluminium and chlorine, aluminium chloride. Such types of salts, those are normal salts. And the preparation there is a direct combination. Now let's look at the next preparation of salt. Now the next preparation of soluble salts that we'll be looking at will be involving acids. Most of, actually the rest will be involving acids. That is, there is something that we are going to react with an acid. Therefore, There are some points that we are supposed to note before we look at this. So I believe that you don't have this point somewhere, but you can note them down. The points that should be noted. So the first point that we will note is a repetition, but we can write it down, is ensure you always add a solid or metal to dilute acid. Are we together on the points? Remember we said never add acid to a metal. Never add acid to a solid. So the first point we are saying, yes? The first point to note is that add a solid or metal to a dilute acid. Add a solid or metal to a dilute acid. That is very important. In other words, we are saying never add the acid to solid.
To the metal.
The second point, which is also very important, is that add the solid or the metal in excess. Add the solid or the metal excess. That is now the second point. The first point was add the solid or the metal to the dilute acid. Then the second one is now you add the solid or metal to, and it should be in excess. And why are we saying that it should be in excess? This is just to ensure that all the acid has reacted. Are we together? The third point, remember these points will apply to all these steps that we are going to look at. So it's important to note them. So you say that the first one you add the acid or the metal to the solid or the metal to dilute acid. The second one you add the solid or the metal in excess. And we're saying that the reason as to it should be in excess is to ensure that all the acid has reacted. Now the third point, which is very important, and you note it down, is that after completion of reaction, filtration is done. Filtration is done to remove. If you are having a challenge, just mute yourself.
Pardon.
I'm on the third point. The third point. After completion of reaction, filtration is done to remove excess solid or metal. After completion of reaction, filtration is done to remove excess solid or metal. Remember in the second point we said that the solid should be in excess. So once the reaction is complete, filter to remove the excess solid or metal.
Yes, madam.
The fourth point is that the filtrate is then heated to concentrate. The filtrate is heated to concentrate. The filtrate is, I'll explain the point. The filtrate is heated to concentrate, then allowed to crystallize. Filtrate is heated to concentrate, then allowed to crystallize. Remember, in the third point, you've already filtered. And once you've filtered, you now have a filtrate. When you're filtering on the third point, you are just filtering to remove any excess metal or solid that was unreacted. Then on the fourth point, remember what we are interested in is the solid part. So the filtrate that you have, ensure that you heat it to concentrate. Heating to concentrate is just the same as you're trying to crystallize it. What we are talking about the other time, that you now heat it and then you dip a glass rod. So instead of explaining all those points, you say that you heat the filtrate to concentrate. And then after that, you allow it to crystallize. After that, the last 2 points are very important. After that, wash with distilled water. The crystals that you now have, you then wash them with distilled water. You wash with distilled water. Remember, we were talking about there was reaction taking place. So to ensure that you have pure crystals, ensure that you wash them with distilled water. And finally, dry between filter papers. Dry between filter papers. When you're saying you dry between filter papers, we mean just because when you're carrying out filtration, you used filter papers. So just the crystals that are in the filter paper, just place them somewhere and allow them to dry. Don't heat again. Just dry them between filter papers.
Excuse me, I have a question.
Yes.
What if this crystals obtained when you wash it with distilled water? Won't the salts dissolve in the distilled water if the salts are soluble? If the salt is soluble?
When you're washing it with distilled water, not all of, after forming the crystals up there, it will not dissolve. You're just washing, it will not dissolve. And
Even
ensure
if
that you don't stir. You don't stir. You just, washing with distilled water, we mean you just pour some distilled water onto that solid and then let the distilled water pass. It will not dissolve. Actually, I believe that when we'll be back, we'll do it practically. You realize that it does not dissolve. You're just washing. That is just pouring liquid, the distilled water on it, and then you're just leaving it. You're not stirring, you're not doing anything. Just pouring the distilled water over it. And then finally, the crystals that are remaining, you dry between filter papers. Those are the, how many points? 6 points that are very, very important. That is when we'll be looking at now the other ways of preparing soluble salts. Ensure that these points, you note them, you know them. Now, back to preparation of soluble salts, we've looked at the first one. So let's look at the second way of preparing soluble salts. The second way of preparing soluble salts is reaction of acid and a metal. Reaction of acid and metal. And just to ask, we looked at such a reaction in when you're looking at acid, bases, and indicators. Now, when you react an acid and a metal, what are the products formed?
Salt and hydrogen gas.
You get salt and?
Water.
Hydrogen gas.
No, somebody's saying salt and water. We are reacting an acid and a metal.
Hydrogen gas.
That's correct. We form salt and hydrogen gas. Now, how do you know that there's a gas that has been formed? What tells you that there's a gas?
Bubbles.
Effervescence.
Effervescence. Correct.
Effervescence.
Effervescence.
Somebody
Effervescence.
Effervescence. It is effervescence. That is what will tell you that
Bye-bye.
a gas has been formed. So in this case too, we're expecting that when you react an acid and a metal, there'll be formation of a salt and hydrogen gas. Now, what we are expecting is that there'll be effervescence. Now, what will tell you that the reaction is complete? What will tell you that the reaction is complete? How will you know that the reaction is complete?
Effervescence stops.
That's correct. When effervescence.
Nitrogen.
Remember, you don't know that the gas formed this hydrogen gas until you carry out the test. So what will tell you that there's a gas that is being produced is the presence of effervescence. And then once the effervescence stops, it means that the reaction is complete. So, for example, if we want to prepare zinc sulfate salts, and then which metal will we use?
Zinc.
If we want to prepare zinc sulfate salt, which metal will we use?
Zinc.
Metal, correct.
Zinc.
Which acid?
Sulfuric 6 acid.
Sulfuric 6 acid.
Sulfuric 6 acid.
Sulfuric 6 acid.
Acid, that is correct. Now, if you were to look at the steps, what is the first thing that you will do?
Put the zinc, the dilute
Add zinc metal
In the dilute sulfuric
Add the
6
zinc
acid.
to the sulfuric 6 acid.
There's a point that I'm waiting for that you've not talked about.
add excess zinc.
You add the zinc to the
Add
sulfuric.
excess zinc to the sulfuric 6 acid.
That's the point that I was waiting for is correct. Somebody has said it. We add excess zinc to dilute sulfuric 6
acid.
Add excess zinc metal to dilute
Sulfuric 6 acid.
After that, what do you do?
When effervescence has stopped,
After that, you do
filter the excess zinc metal.
So we say when effervescence has stopped, filter to remove excess zinc metal.
Zinc.
So when effervescence has stopped, filter to remove excess. You filter to remove excess or the unreacted zinc, and then after that,
the filtrate is heated to concentrate, then allowed to crystallize.
correct. After that, you heat the filtrate to concentrate, and then you allow it to crystallize. Then the last 2 points. Next.
And washed with distilled water.
Wash with distilled water, and then
Dry between filter paper.
Dry between filter papers. That is very, very, very important. Those are the steps to be used. Those are the steps to be used. Whenever we are preparing any soluble salt using an acid, ensure that you remember these steps. So those are some of the ways of preparing. And by the way, I'm giving you 1 minute is too much, 30 seconds to write a balanced chemical equation between zinc and sulfuric 6 acid. 30 seconds, and then you will tell me what you've written actually. Now that I can't see exactly what you've written,
Done.
your 30 seconds are over.
Done.
See through?
We are done. Yes.
How do you write zinc?
Zn.
Capital
Zn.
N.
What is the state symbol for zinc?
solid.
Solid.
Solid. Plus what?
H2SO4.
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 What is the state symbol?
H2SO4.
Aqueous.
Aqueous. Then the products. What are the products?
ZnSO4.
Zinc sulfate
Sulfate.
Plus
ZnSO4.
plus.
State simple aqueous plus
Hydrogen gas.
hydrogen gas H2.
Did you write hydrogen gas?
H2.
H2.
H2. Is the equation balanced?
Yes.
Yes.
Or how do you balance the
Yes.
equation?
It's already balanced.
It is
It's already
balanced.
balanced.
It is balanced.
Hey.
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 The next, that equation is balanced. The next equation, also 30 seconds. An equation between magnesium and hydrochloric acid. Magnesium metal and hydrochloric acid. 30 seconds. Or you have your notes you're copying.
MgCl2.
Are you through?
Yes.
What have you written?
Mg plus
HCl.
2HCl. 2HCl
HCl
plus
Equals to
2HCl
MgCl2 plus H2.
is equals to
what
is
now?
equals to
MgCl2 plus H2.
Mg2 plus H2.
Somebody saying is equals to. You've
Yeah.
written equals to.
Oh my Jesus.
How do you say equals to? You're not doing mathematics.
Waiting for Mungu to work on you, I'll jumpstart the process. Kiss FM, good morning. Morning. How are you doing, bro?
Lazima redio.
Okay, the next way of preparing soluble salts. The next way of preparing soluble salts. So far we've looked at two ways, two methods, and the next method of preparing soluble salt is reaction of carbonate or hydrogen carbonate with acid. Reaction of carbonate or hydrogen carbonate with an acid. Carbonate or hydrogen carbonate with an acid. And also, to take you back, how do we, if we react a carbonate or a hydrogen carbonate with an acid, what are the products formed?
Hydrogen gas, carbon dioxide, and water.
Salt plus carbon dioxide.
Salt
Plus what? Plus
no.
And water.
salt.
What are the products formed? Salt?
Water.
Carbon dioxide, water.
Carbon dioxide and water.
Salt, carbon dioxide, and water.
That's correct. Those are the three things that are formed: salt, carbon dioxide, and water. So whether we are using a carbonate or we are using a hydrogen carbonate, the products are still the same. That is salt, carbon dioxide, and water. And still, carbon dioxide gas is produced, and therefore you will see effervescence. And now, when effervescence stops, then you'll know that the reaction is complete. Just the same way we looked at the other one earlier on. Suppose we have calcium carbonate and nitric 5 acid. Suppose we have calcium carbonate and nitric 5 acid. What are the steps that we are going to use to prepare calcium nitrate salt? What are the steps? We are having calcium carbonate and nitric 5 acid.
Kamel Kiswahili ni dini Jim, nimesahau. Ngamia.
What are the steps used? Which is the first step?
You add excess calcium carbonate to the nitric acid.
Add excess calcium carbonate to dilute nitric 5 acid. That is correct. Next.
And after that, you
After completion of the reaction,
say stop.
remove the test solid metal.
After effervescence has stopped, you do what?
Filter
Filter.
to remove the
Remove
excess solid.
filtration is
Remove
done.
excess
Remove the
calcium carbonate.
excess solid.
So filter to remove excess.
Solid.
Excess solid.
Calcium carbonate.
Solid.
Calcium
Of course,
carbonate.
you already know the solid. So can you just mention it? Filter to remove excess what?
Calcium carbonate.
Calcium
Excess
Calcium
nitrate.
carbonate.
Filter to remove excess calcium carbonate. After that,
You heat the
Wash with distilled water.
what are you
you heat
washing?
Oh, heat the filtrate to
Heat the
concentrate.
filtrate.
Heat the
Concentrate and
filtrate
allow
to
it.
concentrate and allow it to
The filtrate
crystallize.
to concentrate.
Then
And
allow
then
it to crystallize.
Allow
allow
it
it
And
to
now wash it
crystallize.
with distilled water.
Allow it to crystallize.
Wash with distilled water. Then finally dry between
Wash with distilled water.
Filter papers.
papers.
Dry between filter papers.
Now, those ones are general steps to be used.
Excuse
But
me,
when,
sir.
yes, there's a question.
My question is, do you use zinc powder or zinc plate?
Where? Oh, the first one. We always use
Yes,
the
do
powder.
you use zinc powder?
Powder is always preferred. Powder is preferred. So if you have a solid that is in pellets, we always prefer use powder. Powder form is preferred. Yes. So I'm going through this step, and I was just saying that the points I gave, those are general points. But when you now have something specific, give your answer, and in your answer, ensure that you become specific. For example, in this case, we have calcium carbonate and we also have nitric acid. Therefore, you now have, you already have, or you know what you are reacting. Don't say that add the solid. No. Talk about add excess calcium carbonate to dilute nitric acid, because you already know what you have. We are having calcium carbonate and nitric acid. So don't say add excess solid to dilute acid. No, be specific and say add excess calcium carbonate to dilute nitric acid. Then the second step you say, after that you say, after completion or when effervescence stops, filter to remove excess calcium carbonate. Filter to remove excess calcium carbonate. And then after that you say, what is the name of the filtrate that we are having here, by the way?
Calcium nitrate.
Calcium nitrate.
Calcium nitrate solution.
But at that given point, is not a must that you talk about calcium nitrate. You can just talk about, you heat the filtrate to concentrate and allow it to crystallize. Heat the filtrate to concentrate, allow it to crystallize, and then wash with distilled water, then finally dry between filter papers. And as usual, take your 30 seconds to write a balanced chemical equation between calcium carbonate and nitric acid. 30 seconds. Your 30 seconds begins right now. Calcium carbonate and nitric acid. Balanced chemical equation. Balanced chemical equation for the reaction between calcium carbonate and nitric acid. Ensure the equation is balanced. Oh.
Why didn't you tell me he was stalking this?
Done.
Done.
It's done.
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 tell me what you've written.
CaCO3.
CaCO3.
Done.
Set symbols.
Solid.
HNO3.
Set symbol done. Plus.
CaCO3, set symbol solid, plus 2HNO3, set symbol AQ, gives us
HNO3 to give you
Ca in brackets
Ca
NO3,
NO3
2, set symbol solid, plus H2O, set symbol liquid, plus CO2 gas.
Okay, just a minute. CaNO3 bracket 2. What is the set symbol?
Aqueous.
Aqueous.
Not solid. Remember, we are preparing a soluble salt.
Please repeat.
I repeat the equation.
Yes.
So the equation is CaCO3 in solid
Symbol
state
S.
plus, there's a 2 there to balance. So 2HNO3 in aqueous state to give you Ca, and then we open the bracket, NO3, close the bracket, then there's a 2 there. The state symbol is aqueous plus, of course, water is H2O, state symbol is liquid, plus CO2, state symbol gas. Did you get that equation right? Did you get the equation right?
No.
Yes.
You did not get it right. So you've forgotten how to write equations or how to balance them. Okay, let me give you 1 minute in this. 1 minute, write the equation for the reaction between, I'm giving 1 minute now. Question for the reaction between sodium carbonate and nitric 5 acid. Sodium carbonate and nitric 5 acid. Write a chemical equation, a balanced chemical equation between sodium carbonate and nitric 5 acid. So complete the equation by writing the products and ensure you balance it.
NaCO3.
No.
Done.
Na2CO3.
Is it done?
Yes.
Are you through?
Yes.
Yes.
Okay.
Yes.
Okay, start.
Na2
CO3.
Na2
CO3
CO3
plus
what is the state symbol?
Solid.
Plus
Na2CO3 in bracket solid plus 2HNO3.
2HNO3.
AQ to give you
2NaNO3. State symbol solid.
2Na2H2O. To give you 2NaNO3 aqueous plus H2O plus CO2.
Yes.
Yeah. Okay, that's correct. I'll repeat that and then I'll tell you what to consider before writing the states. symbols because I can see on the product
Lebana,
side you're
what is
having
this?
problems with the state
Still
symbols.
is someone disturbing us on the screen.
That equation, we have Na2CO3 in solid state plus, there is a 2 to balance the nitric 5 acid, so 2
Excuse me, madam.
HNO3 AQ, just a minute, to give you 2 NaNO3 aqueous plus H2O liquid state plus CO2 in gaseous state. Yes, there's a question somewhere. Somebody had a question?
Excuse me, Chair.
Yes.
Under sodium carbonate, can you write excess?
No.
Excess.
If we are
Okay.
writing, when you're now writing the chemical formula or the equation, we don't write excess. But when you're writing the steps, we write excess. Now, just to explain something, I can see there's a problem in the state symbols, especially for the products formed. Now, remember, these state symbols depend on whether the salt is soluble or insoluble. If the salt that you are preparing is a soluble salt, the state symbol should be in aqueous state. If the salt you are preparing is a soluble salt, the state symbol should be in aqueous state. Are we together? If you are preparing an insoluble salt, then state symbol will be in solid state. Remember, all acids, the state symbol
Repeat, please.
Pardon.
The states, okay, I'll repeat. The state symbols of acids is always in aqueous state.
Oh.
Now, when you are now coming to
Yes.
the product side,
Yes.
how do you know that we are now talking about an aqueous state or a solid state? Now look at the salt that is formed. If the salt formed is a soluble salt, if the salt formed is a soluble salt, then the state symbol should be aqueous. Aqueous meaning
Aqueous.
it can be in a solution form. AQ.
Aqueous.
If the salt formed is a insoluble salt, then the state symbol will be in solid state. For example, if I say we have copper 2 sulfate, if I symbol for copper, what will be the state symbol for copper 2 sulfate? You have to know. You have to know whether we are preparing whether copper 2 sulfate is a soluble salt or insoluble salt. So if it is a soluble salt, the state symbol will be AQ. If it is insoluble, then the state symbol will be S. So the question is, what is the state symbol for copper 2 sulfate?
S.
Solid.
S. Solid.
Solid. What did we say about sulfate? What did we say about sulfates in terms of solubility?
All sulfates.
All sulfates are soluble except
barium and lead.
Barium?
Barium and lead.
All
Barium,
sulfate
lead,
and
and
sulfite salts are soluble.
And calcium.
Barium, calcium, lead.
Barium. So is copper 2 sulfate soluble or insoluble?
Soluble.
It is soluble. So what will be the state symbol?
Soluble.
AQ.
Aqueous.
It will be in aqueous state. That is correct. Next, unless there is another question. Somebody is requesting we repeat the steps in preparation of salt. We are saying we add excess solid or metal to dilute acid. The second step, ensure that the acid or the metal is in excess to ensure that all the acid has reacted. After that, when the reaction is complete, that is when effervescence stops, filter to remove the excess solid. Then the filtrate is then heated to concentrate, then allowed to crystallize. The last two steps, you then wash with distilled water and finally dry between filter papers. Even if you are at home, please don't forget how to write balanced chemical equation, because wherever I am, I can realize that there is still problems with balancing chemical equations. Remember, we said in writing and balancing chemical equations, you must always practice. If not, you will forget. And remember, the periodic chemistry is the key to everything chemistry. So that is the third way of preparing soluble salts. The fourth, can you go to number 4? Or there is a, unless there's a problem? Unless there's a question?
No.
There's no question, let's go to the next way of preparing soluble salt. The next way of preparing soluble salt is a reaction of insoluble base and acid. Reaction of insoluble base with an acid. Reaction of insoluble base with an acid. Now, just a minute. What did we say about solubility of bases? What did we say about solubility of bases?
Soluble.
All bases are
all bases are insoluble,
All
except
bases
sodium,
are insoluble except
ammonium.
sodium,
Potassium, and ammonia.
potassium, and
Potassium,
ammonia.
ammonium.
Except
Yeah, that is correct. All,
sodium, potassium, and ammonia.
so when you're saying that, we say that all bases are insoluble except the bases of sodium, potassium, and ammonium. Those ones are the bases that are soluble. Otherwise, all other bases are insoluble. So this one here, we are talking about reaction of an insoluble base with an acid. So if you're talking about insoluble base, and remember, bases can either be oxides or hydroxides. Oxides or hydroxides. So when you're saying, when you're talking about insoluble bases, we're talking about the oxides or hydroxides of all the other bases or of all the metals except those ones of sodium, potassium, or ammonium. But remember, we don't have ammonium oxide. We only have ammonium hydroxide. So basically, we'll be reacting an insoluble base with an acid. Still, we are having a reaction between a base and an acid. What are the products formed? What are the products formed? When you react an acid and a base, what are the products formed?
Salt and water.
Salt and
water.
Salt and water only. The products formed are just salt and water. And remember, here we are adding an insoluble base. And since we are adding an insoluble base, let me repeat that part. Since we are adding an insoluble base, what is the state symbol of the base that is being added?
Excuse me, teacher.
Yes.
I've not understood the point of bases. Are all bases soluble or insoluble?
All bases are insoluble, except Sodium,
Potassium
potassium, and
Ammonium.
ammonium.
Those are the only bases that are soluble. Otherwise, all other bases are insoluble. So I'm saying this. We're just saying that the bases are insoluble. If bases are insoluble, what is the state symbol?
Solid.
Solid.
Oh,
Solid because they'll form an insoluble salt.
suppose we have lead 2 oxide and nitric 5 acid. Lead 2 oxide and nitric 5 acid. We have lead 2 oxide, which is which is an insoluble base, and nitric 5 acid. Quickly, give me the steps which will be used to prepare the soluble salt. I'm saying you are given lead 2 oxide and dilute nitric 5 acid. Give me the steps. Quickly give me the steps used to prepare lead 2 nitrate. The first step.
Add excess lead 2 oxide to dilute nitric acid.
Correct. Add excess lead 2 oxide to dilute nitric 5 acid. Next step.
After the reaction is complete. After the reaction is complete, you filter to remove the 2 oxide.
Excuse me, somebody is talking about effervescence here. I started by saying the products form the salt and water. There is no gas. There is no gas here. So the first step here is you add excess lead 2 oxide to dilute nitric 5 acid. After that, filter to remove excess lead 2 oxide, the way someone has said. Next, after that, what do you do to the filtrate?
You wash it to concentrate.
You wash it to concentrate. You heat it.
No, you heat it first to concentrate, then allow it to crystallize.
Heat it to concentrate, then allow it to crystallize, and then
wash it to concentrate.
Do you wash to concentrate?
Wash it with distilled water, then dry remaining crystals with distilled water.
You heat it to
Wash
concentrate.
with distilled water, and
Then dry
finally,
the remaining crystals between filter papers.
okay, let me repeat the steps. Confirm with yours if you have the correct steps. Is that okay? So the first step is add excess lead 2 oxide to dilute nitric 5 acid. Add excess lead 2 oxide to dilute nitric 5 acid. Then after that, to say filter to remove excess lead 2 oxide. Filter to remove excess lead 2 oxide. Next, we talk about heat the filtrate to concentrate. Heat the filtrate to concentrate, then allow to crystallize. Heat the filtrate to concentrate, then allow to crystallize. Then we say, wash with distilled water, wash with distilled water, then dry between filter papers. Wash with distilled water, then dry between filter papers. Did you get all the points correct?
Yes.
If it was 3 marks,
Yes.
how many marks you have gotten?
Yes. 0.
Somebody
Come on,
0,
guys.
somebody 3.
I
Okay,
don't
right.
give mixture.
Zero. Got it all.
Yes, somebody has a question, yes?
When in the reaction of acids with the carbonates and hydrogen carbonates, is there effervescence?
Yes, because there is production of carbon dioxide gas.
So
Effervescence will
that
always be there when there is a gas being produced.
thank you.
Here we are not talking about effervescence because there is no gas. What we are the products are just salt and water only. There is no gas. But whenever there is a gas, there has to be effervescence. Now there's a question that you're supposed to ask, but you're not asking. So let me talk about it. How will you know that this reaction is complete? Remember, when there was a gas, if effervescence stops, then we know that the reaction is complete. In this case, we don't have effervescence. How will we know that all the acid has reacted?
Neutralization reaction.
How will you know that all the acid has reacted? Now remember what we are doing here is we are adding excess solid to the acid. So what will tell you that the reaction is complete is if no more solid dissolves. If no more solid dissolves, let me repeat that point. I'm saying, in this case too, we have to filter when the reaction is complete. But how will you know that the reaction is complete? What I'm saying is, you will be adding the excess acid until no more, you'll be adding excess solid until no more solid dissolves. So once the solid is not dissolving, you now know that the reaction is complete. So that is how you will tell that this reaction is complete. Reaction of insoluble base with an acid. We are adding the insoluble base, which is in solid form, and we are adding it in excess. So we will know that the reaction is complete if no more solid dissolves. That is, as you continue adding, you realize that the solid that you are adding does not dissolve anymore. That is what will tell you that the reaction is complete. Whenever there is a gas being produced, if effervescence stops, then we know that the reaction is complete. So ensure you know the difference, or ensure you know how to tell when the reaction is complete. Unless there is a question on that. 30 seconds. 30 seconds, because that reaction is very easy. 30 seconds. Write a balanced chemical equation for the reaction between lead 2 oxide and nitric 5 acid. 30 seconds. I believe some have already written the equation. So 30 seconds. A balanced chemical equation between lead 2 oxide and nitric 5 acid. Yes. Are you through?
Yes. Yes. Yes.
Okay. Tell me what you have written.
PBO.
PBO. Solid. Plus
2HNO3.
2HNO3 aqueous to give you
Yes.
PB into bracket NO3
close
the brackets
2
H simple is aqueous.
AQ
plus
plus
H2O.
H2O.
Liquid.
Yeah,
That simple liquid.
that's correct. So I'm repeating the equation. What you've written is correct. So we have PBO in solid state plus, there's a 2 to balance the equation, 2HNO3 in aqueous state to give you PB, you open the bracket, then you have NO3, close the bracket and have your 2 there in aqueous state, plus H2O in liquid state. Unless there is a question, I'll go to the last method. Yes.
Is this salt soluble or insoluble?
Which one?
The lead.
The lead nitrate.
Yes.
Remember, all nitrate salts are soluble. So if you prepare lead nitrate salt, it is a soluble salt. All nitrate salts are soluble. In nitrates, we don't have an exception. All of them are soluble. So any nitrate salt that you form will always be in aqueous state because all nitrate salts are soluble. So lead 2 nitrate there is a soluble salt, aqueous state. Have I answered your question?
Yes.
The last one because of time is a reaction of soluble base with dilute acid. Reaction of soluble base with dilute acid. Remember, we were looking at insoluble base. Right now, we are looking at soluble base. Can you give me an example of a soluble base?
Sodium hydroxide.
Potassium hydroxide.
Potassium hydroxide, sodium hydroxide,
Ammonium
Ammonium
hydroxide.
potassium
ammonium
oxide.
hydroxide,
Sodium hydroxide.
Potassium hydroxide.
Potassium hydroxide.
potassium hydroxide. Actually, the soluble bases are just 5. That is the sodium, sorry, they're just 3, sorry. Sodium hydroxide, potassium hydroxide, ammonium hydroxide. Those ones are the soluble bases. So, in this case, we are now adding a soluble base, meaning that the base is in aqueous state. We are adding a soluble base to dilute nitric 5 acid, or a dilute acid. Now, in this case, how will we know that the reaction is complete? This is a situation whereby we now have reaction of a soluble base, or what we call an alkali, with a dilute acid. Such a reaction is called neutralization reaction, which I believe we all know that neutralization reaction is a reaction between an acid and a base to give you salt and water as the only product. The difference between this and what we were talking about earlier on is that earlier on we were talking about an insoluble base. Here we are now talking about an alkali. So, and we know that an alkali is a soluble base. So when we're reacting an alkali with a dilute acid, we are coming up with salt and water as the only products. So we have neutralization reaction. Now, how will we know that the reaction is complete in neutralization reaction? Remember, we are now adding a soluble base, which is in aqueous state. In other words, it is in solution state. So we are now not adding any solid. We're just adding a solution to another solution. How will we know that the reaction is complete? Any trial?
We use an indicator.
That's correct. Very, very, very correct. We use an indicator. So there is the use of an indicator here. And remember the indicators that we talked about. What are some of the indicators that we have in the lab? Mention some few indicators.
Phenolphthalein.
Phenolphthalein, methyl
Phenolphthalein indicator.
Methyl blue.
methyl orange,
Methyl
Bromothymol blue,
litmus paper,
litmus solution.
Litmus paper. That's very correct. Those ones are the indicators that we have. So what will tell us that this reaction is actually complete is the color change that will be seen in the indicator. And when the reaction is complete, we now say that the reaction has reached its end point. And the end point is seen when the indicator changes. For example, if we are using phenolphthalein indicator, what is the color of phenolphthalein in acid?
Colorless.
In base?
Pink.
Pink.
In base it is?
Pink.
Base is pink.
Pink.
So if at all, we added some phenolphthalein indicator in a base. Suppose we added some phenolphthalein indicator in a base, say sodium hydroxide, we expect the color to be pink. Is that right?
Yes.
Now, when we are adding an acid to it, we expect the color to change from pink to colorless. So that is what we look at. Neutralization reaction.
Reaction. Au simi kwa percent? 33 inaweza keti ile lesson moja. Hii ni mathematics ndio?
Yes.
Utachaji.
Is this experiment the one used by the Form 3s and the Form 4s when they are doing their practicals?
Yes.
Oh.
It is the titration experiment called titration, whereby we have the burette. I believe you know what the burette is.
Yes.
This is the titration experiment that is commonly used. And you will also do it. We use an indicator, and the indicator is used to show the end point. End point is the completion of reaction.
The reaction.
And you know the end point. You know the end point when the color of the indicator changes. Is that okay?
Yes.
Unless there is a question. Unless there's a question.
So when
what is titration?
I was answering a question that somebody asked, if this is the experiment that is used by the Form 3s and Form 4s, and that is when I mentioned titration. Titration is an experiment which you will do when you reach Form 3. Somebody had a question.
How do we know when endpoint is reached?
How will you know that the endpoint has been reached? You know the endpoint has been reached when the color of the indicator changes. For example, if you are using phenolphthalein indicator, if it was in a base, that is, if it's in pink, you will continue adding the acid until the color changes from pink to colorless. If it now turns to colorless, then you know that the endpoint has been reached. So the endpoint, you know that, yes?
Si pia kwa acid ziko na kwanga colorless.
Yes. Continue with the question.
If it's in acid and it's colorless, how will you know it's neutral or if it's acidic? Zote ziko colorless.
Remember, we are reacting an acid and a base. So we expect that the product that is being produced should be neutral. So the color that we are expecting right now is the color in neutral solution. Therefore, it will be colorless. We are expecting the color in neutral because we are reacting an acid and a base, and the product we are expecting is a neutral salt and water. So the color change expected should be the color change in neutral solution. Any other question? So if there's no question, let's do a quick recap in the next 2 minutes of what we've done. We've looked at preparation of soluble salts, and we've talked about like 5 ways of preparing soluble salts. The first one was direct combination, whereby we directly add or directly react a metal and maybe just 2 elements, sodium and chlorine. You get sodium chloride, and that one will give you the salts. And then we looked at the other method of preparing soluble salts. We looked at reaction of acid and a metal, and we went through the steps that are used. We say that an acid and a metal, ensure that you add the metal to the acid, and you also ensure that the acid, the metal is in excess. Now, when you're adding a metal to an acid, there will be production of effervescence because a gas will be produced. So once the effervescence stops, that is what will tell you that the reaction is complete. Then after that, you filter to remove the excess metal or the unreacted metal. After that, the filtrate that has been produced, you heat it to concentrate. Heating and replace the glass rod. And then after that, you allow to crystallize. Once the crystals are formed, you just wash the crystals with distilled water, and then you dry it.
Excuse me, teacher.
Yes.
When we are adding the soluble base, are we adding it in excess?
Base. That is on the
Yes.
last point. Now, when we are adding this one, we'll be adding using a burette, and we're using a burette because we'll be adding controlled amount. That is, you'll be adding dropwise, just dropwise. We don't add in excess here. We'll be adding it dropwise, dropwise, dropwise. And that is why in neutralization, we have to use a burette. Remember, burette has a tap. So the tap will allow you to open it and close it the way you want. So you'll be adding controlled amount, and we always advise that you add it dropwise. So you'll be adding drops, just dropwise until the color changes. So here we don't add excess alkali. We don't add excess alkali. Unless there is any other question.
Excuse me, Chair.
Yes.
Let's say in the last one for reacting a base with an acid, and use phenolphthalein as the indicator. How will you know if it's neutral? And yet, when an acid, when it's put in an acid, it's also colorless, just as when it's put in neutral.
So you'll always be given a guideline. You'll always be given a guideline, or you'll always be told. And most of the times, you will be adding the indicator to the base. Most of the time, you'll be adding the indicator to the base. And then, for example, if you're having the phenolphthalein that you're talking about, and you're having sodium hydroxide, you'll add 2 to 3 drops of the indicator to the sodium hydroxide. And once you add the indicator, the phenolphthalein to sodium hydroxide, the color will be pink. And then after that, you'll now be adding an acid. And remember, we are adding controlled amount of the acid to the base here. Once we are adding an acid to the base, we expect that a neutralization reaction will take place. Therefore, the end result or the color that will be produced should be the color in neutral solution, which will be colorless. Unless there is any other question.
Excuse me, teacher.
Yes.
Excuse me, teacher. Should you stir those solutions?
You don't stir. We always swirl. You know what we mean by swirling? If you are using a conical flask, you just swirl. You don't stir. Remember, stirring is using maybe a stirring rod, but we don't stir. You just swirl. Nazungusha tu, nazungusha. You don't stir. Because of time, the last question.
I was asking.
Yes.
in the reaction of insoluble base and an acid,
Yes.
we say the reaction is complete when no more solid dissolves in the acid, but
Yes.
the base is insoluble.
The base is insoluble because it is the base is insoluble. That is why it is a solid. So as you continue adding it, there will be reacting. It will not be dissolving. Yes, it will be reacting. So once you realize that there is no more reaction, as much as you continue adding, remember if the reaction is taking place, it will, let me use that simple word. You will not be seeing, it will be disappearing. Let me use that word so that you can understand what we mean. So as you continue adding, you realize that you add, and there is, it is still there. It is not disappearing. That is what we mean by until no more dissolves. Is that okay? Have I answered your question?
Yes, thank you.
Yes.
Having done that, because of
Yes.
time, I would like to stop at that point. We'll continue, and if you have a question, keep it. We'll answer it in the first few minutes in the next lesson. Have a nice time.
Thank you. Bye.
Thank you, and same. Bye.
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 Bye. Bye.